Hello everyone. In this video, let's take a look at a couple examples where we will be using our basic properties of limits. The properties that we have discussed so far include the limit of a constant and the limit of the identity function. Both of those will come in handy. And the other ones we've taken a look at include the limit of a sum, a difference, and a product. And what all these properties are going to allow us to do is be able to take a look at some basic functions and easily evaluate the limits. So my first example, I have the limit as x approaches -3 of x over 6 plus 2. Now, one thing I want to point out right away is that we do have a little bit of division inside my limit. But we know that we can rewrite division as multiplication. So x over 6, that's just the same as 1/6 times x. And then this is going to be still the plus 2. So these properties, they also work with a quotient. So now I want to use a combination of all of those. And what I'm going to do is I'm going to expand this limit, and it's going to make it easier to evaluate. So this is the same as the limit, and all of these are going to be the limit as x approaches 3. So we have the limit of 1/6 times the limit of just x, and then plus the limit as x approaches -3 of just 2. And once we're at this point, now we're going to use our limit of a constant and the limit of the identity to easily evaluate this. So here we have a constant function. So if I were to graph this, this would be a horizontal line going through the y value of 1/6. So what that means is everywhere on that graph, the y value is 1/6. So no matter what point my x value is approaching, the limit is always 1/6. So that's constant. And we're going to multiply. Here I have an identity function. So our property says that no matter which x value I'm approaching, the limit of this is equal to that value. So remember, this is the line that goes through the origin. It has a slope of 1. So the x values and the y values are always the same. So if I'm approaching -3 on the x, my limit is also going to be -3. And then our last piece is another constant function. So this is going to stay as 2 no matter where we are. And now we can finish up. 1/6 times -3. That's -3 over 6, which is -1/2. And then we'll add 2. And if I add 2, we end up with a positive 1/2. And I'm going to write this as 3 over 2. And so there's our limit. Now, as I'm going through this, you may have noticed one thing. Our limit, our final answer here, is what I would have got if I plug in -3 to my original function. So just to write that out here. So my original function, we have x over 6 plus 2. And if I just plug in -3 to that x value, I do end up with the same thing. I still get 3/2, which is a good observation to make. Now, all this process that we went through here, this is the math that is going on in the background. These are the properties and the rules that we're following. But this is basically what we end up with. So let's do one more example. And I'll just go through the process again. So the limit as x approaches 2 from the right of 3x times 4 minus x. Okay, the first thing to know in this case is I am just looking at this from the right-hand side. But that's totally fine. All of these properties also apply to one-sided limits. So now we can separate this. So we'll be taking a look at the limit. And all the limits will be as x approaches 2 from the right. And then all of these are going to get separated. So we have some product in here. So the limit of 3 times the limit as x approaches 2 from the right of x times And now I have the parentheses here, so I'm going to separate that with another set. The limit as x approaches 2 from the right of 4, and minus the limit as x approaches 2 from the right of x. And now that they're all separate, again, we can use our constant and our identity rules to simplify. So here's the limit of a constant, so that's the same as just the constant. The limit of the identity, so this is going to be equal to whatever number I'm approaching, so this is equal to 2. And then times another constant, so that's the limit there is 4, and then minus, here's the limit of the identity, so this is 2 as well. So we end up with 6 times 2, and our limit is 12. And the same idea, exactly as we saw on the last one, if I were to just plug in 2, I should also end up with 12. So our original function was 3x times 4 minus x. And if I just plug in 2, we have 3 times 2 times 4 minus 2, which is 12. And again, over here, this is the math, and these are the properties that we are following that allow us to do this. It's equivalent to just plugging in 2 and seeing what the answer is. Now, I do have to warn you that this isn't always the case. These are pretty basic functions. These are continuous functions everywhere on the domain, so this works out. There are going to be functions that are undefined in some places, and just plugging in the value is not going to work. So those will come to a little bit later. But thanks for watching.